My professional life is split into half academic, where I'm at Stanford. I do research and teaching in a branch of AI called reinforcement learning. But what I do there is for the financial markets. It's AI for financial trading, and that's my background originally. I spent 14 years at Goldman Sachs and Morgan Stanley doing derivatives trading. My other half is I'm a VP of AI at Target, and that job is firstly thinking about the right problems to solve with AI and the problems that are not so suitable for AI. Let's talk about demand forecasting. It's a fundamental problem in a lot of businesses. In retail, a company like Target, you have 2,000 stores. We sell a lot of products in each store, about 100,000 on average products per store. You have to predict how many units of each product would be sold in each store on a daily basis. That's a hard problem. For things that are fast sellers, the demand is pretty predictable. But there's a lot of items that are slow sellers. There's a lot of substitutability effects as well. I was in Minneapolis earlier this week, and I had to buy a red shirt. I didn't go there looking for a specific SKU. I just wanted to buy a red shirt. A lot of people come there with that type of demand. It's hard to predict what exactly are they going to buy. So these are the things that make it pretty complex. This is a picture of, well, firstly, let me explain how we came up with this picture. So if I look at the last 5 to 10 years of weekly sales data across our network, so this is aggregated sales for a given product across 2,000 stores, that falls into a pretty tight pattern. That's a lot of sales. We're looking at like large numbers here, like 60,000 units sold, but across 2,000 stores. So this is pretty easy to predict. So this is not even modeling. I just plotted the high and the low of the last 10 years of data I saw, and you can do this model. Anybody can do it. You just have to sort of draw a line that goes somewhere in between the highs and the lows, and that would be a reasonable model. But when you look at the same product in a single store, there's a lot of variation. Why is there a variation? Because there's a lot of factors at play here. There is demographics. Weekday versus weekend behavior tend to be different. Weather plays a big effect. The state of the economy matters a lot of times, and a variety of factors. Sometimes celebrity do tweets about our products, and you'll see a big spike. Now, how do you predict those type of things? It's difficult. So this is a problem that is complex. We work on it, but you should never expect that you would get any level of accuracy for predicting, say, a slow seller in a specific store on a specific day. But you need a framework by which you get somewhere in the ballpark. But for something like this, you can actually get pretty accurate. This is your prediction for the entire network. So defining the acceptance criteria of your demand forecast is very important. Personalization, recommending products. You've probably experienced a lot of this on Netflix. Many of these algorithms have been at play for perhaps a decade now. I get very mixed responses from people. Some people are very impressed. Some people find it a little bit creepy about how this machine is understanding you as a person. My wife thinks that it understands her way better than me. But there are some others who are disappointed. They get frustrated. So it's also about how you interact with the machine. So in our context, Target or in retail, here's a woman who wants to buy this blue shirt, and the recommendation system should recommend accessories like this. I'm not a fashion person, so you can judge how well this worked. Looks reasonable. a blue and white matching bag, this nice belt, and this footwear. So how do we do this? Well, you can always use a lot of catalog information. So where is this catalog information coming from? Well, it's seeded by human experts. So if the algorithm studies catalog information, it starts detecting these patterns between certain types of apparel and certain types of accessories, but also to the extent that the algorithm can understand the nuances of the individual. Because what works for one person may not work for another. So there are these two attributes. There's a generic matching. I think color match is a pretty standard thing. Size match is a pretty standard thing. But then you have to zoom into the nuances of specific individuals. I won't get into a lot of details here, but this is a pretty important problem, not just for Target, but for a variety of companies. The main message I want to give you is that the augmented AI is where we are at today. Augmented AI is when some things are done by the machine. There's a task, and in some situations, the machine is in control. In some situations, the human is in control. And then they sort of work collaboratively to solve the problem so that the sum is greater than the parts. So that's kind of the goal of augmented AI. I would really encourage you to think about your business problems, and your default approach should be augmented AI, and that requires human experts to work together with the machine.